All right, I'm back. So the sun came out the other day when I was recording, and by this point there was too much of a glare. So hopefully get these last two pages in, and then actually these two pages in, do together, and then the last two pages will be the pages you submit. All right, so what this is we're going to look at different functional groups. So we're going to look at what happens when we suddenly add other colors like oxygens or nitrogens and different things other than just carbons and hydrogens. And that determines chemical reactivity or special features like we're going to see oxygens. This would be polar, so we'd see pooling. Halides or the halogens, again, we're going to see pooling and stuff. And so these are going to be things we're going to keep building on. Or here we have nitrogen. So these guys are going to give us polarity, which we did not have. All the carbon hydrogen ones were non-polar. So what the R means in each one of these is it can be any number of carbons. So we could add a 1 carbon group on, like I did for this one, or we could add the benzene ring on, and so I could pull this hydrogen off and add my special functional group on, and that would make it something special. And yeah. All right, so let's go ahead and walk through them, and we're going to make it simple. We're going to just always make the R a carbon, and I'll just show it like that with the 3 hydrogens. Again, if you write the carbon in, those sticks mean H. And then we'd have an oxygen, and often they'll just write the H right next to it, like it shows in the picture here, or you can show a line to the H. We are doing structural formulas, so technically you are done. But I know some of you are going to ask this question. The oxygen doesn't show its octet. So in organic chemistry, structural formulas, they don't show the dots, but there are dots. And then also a question came up last night in my office hours, which is every year this question comes up. A reminder, this is not linear. So even though we draw it like that, this is a tetrahedral. And in a tetrahedral, tetrahedral again is this 3-dimensional. And so this hydrogen is actually being pushed down, and we'd have these little Mickey Mouse arrows pushing it down. So you can show it like that, or you can show it like this original way. It's recognizing that OH has a bend and there's a pull by the oxygen. All right, a halide just means a halogen. So the 7 A's, you can pick your favorite one. Let's do bromine, because everybody always forgets bromine, but you can pick chlorine. Chlorine's a little too greedy. It's such a hoarder. I don't want to give it any more credit than we keep having to. All right, R, and just put 1 carbon. We're going to do practice on the next page where we'll put more than 1. And then you put the nitrogen, and again, you can write it like this, NH2, or you can show the hydrogens around it like that. And I am recording, sorry. Again, this is considered correct, as is that, but for many of you, it will be helpful to remember nitrogen has that extra lone pair on it. And so this would have a pyramidal, a tetrahedral pyramid. All right, this is an oxygen in the middle. So that's what ethers are. So if you're a Curious George fan, and I'm going to show this 2 ways. So you can take a moment before you write it. You could show it like this with the CH3s on each side of it, which is how we'll see it on the next page. But again, remember the oxygen really has these Mickey Mouse ears. So really, these carbons are being pushed down. And if it helps you, put the Mickey Mouse ears and push them down. And you can show them how I did there, where I write the hydrogens in, or you can show the lines, or when we get to the next page, I'll be doing it with the zigzags again. I just trying to show you different ways. So our first one is an alcohol group. Whenever we see an OH, that's the only oxygen we see is an OH, that is an alcohol group. On this next one, we're going to see an OH, but there's an extra oxygen, so there's 2 oxygens there, and we'll get to that in a minute. These are called halides. An amine is the nitrogen group. There are also amides, but we're not going to worry about them. They're awesome. That's what a peptide is, an amide bond. And then an ether is just the oxygen is the monkey in the middle. So carboxylic acid is the one I actually had made for you. and this is 2 oxygens. You never have oxygens in a row. They would come when you see a picture like this, and again, that is why I'm teaching this, is the oxygen, one of them will be double bonded to the carbon and one of them will be an OH. And this then would be your other piece. Down here, it shows it much nicer at the bottom of the page, and it actually shows you the bend that this is going to come out as a planar triangle. So these are carboxylic acids, and it has to do, and if you want, you can draw your 1 carbon group there just to keep it simple. It is this double oxygen that makes these special, that this double oxygen creates the double pull of the electron. So they're both really greedy, and that pulling allows this hydrogen to pop off really easily. And that's what an acid is when a hydrogen pops off really easily. Acids donate hydrogen, and this is a hydrogen without electrons, so it's actually a proton. So they are proton donators. All right, an ester, oh, esters are so wonderful. All those flowers that are out there, this is the unfortunate thing of being a chemist. You see the flowers and I think esters. And so Isaac and Riley, who took the Chem 105 with me, they probably have been warped for life too. So things that smell beautiful, so perfumes are esters. And what an ester looks like, again, we see this double oxygen. It means that it has this formation, but instead of the hydrogen, we replace it with carbons. And this can be 1 carbon, it can be 6 carbons, and then there can be carbons on the other side of this also. Now, it's no longer an acid. These would have dots, of course. What happens? Acids have one of the foulest smells that is out there. So vinegar, you might think vinegar smells really nice because we associate it with like salads and stuff. But as you get more and more carbons here, the smell becomes like a goat. Caprylic acid is 5 carbons. So in case you don't want to go and smell a goat, you could try this experiment. Wear your socks around for a day or 2 and then smell your socks, or don't. Gnomes kind of have a fetish about socks. Here's our gnome. They're going to tell you, don't smell the left socks. They smell like carboxylic acids. And yeah, or if you haven't done your laundry for a month, but everybody's done their laundry now because we've all been locked in. That's a carboxylic acid smell. The other one that smells really bad are amines. That's the rotten fish, rotten meat smell, and that's because the amino acids, the proteins are broken down to amino acids. Esters smell so wonderful. So all the flowers, perfumes have esters. Ketones and aldehydes are variable. The small ones have terrible smells. The smallest ketone is acetone, so fingernail polish remover. The smallest aldehyde is formaldehyde, which is really nasty. But as they get more and more carbons, they actually start having a more fragrant smell. So these guys, what's different is they only have 1 oxygen. And why, though, they're in the second row is it's a double bonded oxygen. There's no hydrogen on that carbon here. So this oxygen on the ketone is double bonded, and we'll add a carbon. And so it's different from up here in the ester. There was an oxygen in between. This oxygen's on the carbon, which means it has to be sticking off, or else the carbon doesn't have enough bonds. So that's a ketone. What's different about an aldehyde is in an aldehyde, this carbon is always at the end. And so this carbon does have a hydrogen, and that actually gives it special properties, like it can be oxidized. This ketone, there's no hydrogen on that carbon, and so it can't be oxidized. That ends up being a big deal when you do a full year of organic chemistry and in biochemistry and nutrition. That's actually a big deal because oxidation is the loss of electrons, if you remember Leo, and that happens in our bodies. And sugars are they're aldehydes, and so they will go through this and cause oxidative damage to our body. All right, so those are the functional groups. And again, you will always have your notes. So you should be taking really nice notes and make sure everything's organized. So when you do your midterm, you can find information that you need and can then deduce it. This is really good practice for your second study set as well. And so what we're going to do, what I would recommend is after I give you quick directions, that you stop my video and you try this. I know Erin's going to do that. And a couple of you will definitely stop the video and try it and then listen and see if you got it. But one of the things we're going to do is the star, we're going to go ahead and do hybridization. We're going to do bond angle and we're going to do geometry. That's really good review. That is something you should be able to do. Even though you have your notes in front of you, if you aren't able to do it innately, the exam's going to be just not really fun for you. The other thing we're going to do is ID the functional group. So let's do that together first. This one, we have the double bonded oxygen. We just have the one oxygen and it's in the middle. So that's our ketone. And ketone doesn't have a Y in it. It's not like a key you put in your door. All right, this one, we have the oxygen. It's just no H, just one oxygen. So this is our alcohol group. This one, we have an oxygen, monkey in the middle. So that's our ether. So again, did you stop the video and try this on your own to see if you could do it? Right down here, we have bromine. That's one of the halogens. So this is a halide. Nitrogen, that is an amino group. So we call it an amine. If you say amino, I'm perfectly fine with that. All right. And down here, oh, we have an OH. Oh, we have a double bonded O. It is not a ketone and an alcohol because they're on the same carbon. We're up here to the acid. So you can, I'm just going to say a carb acid. So it's a carboxylic acid. And then our last one, there's this thing that makes it special is that triple bond. So that would be going back a couple pages. That is an alkyne. And yeah, sorry, looks like there's some guacamole on my sheet. All right, alkyne, like all kind of trouble. All right, let's go back and let's look at the star and do our geometry and all that. So the carbon has 1, 2, 3 things around it. So 3 is planar triangle, right? 3 is a triangle, and we do want to always put the word planar because planar means it is flat. It's two-dimensional. Planar triangle is, what's the bond angle, Janae? We could do like a Jeopardy here, right? For 120 points, it is 120 degrees. And we're going to also do hybridization. So I'm going to see if Edward caught my little early review of it. SP2. So when 3 things hybridize, S is the first thing that always hybridizes, and then 2 P's. So S plus 2 P's gives us 3 things that hybridize, which is a triangle. All right, the next one, 4. 4 is a tetrahedral. And An's raising her hand saying, I know this one. It's 109 degrees. And she is right. And that would be SP3. 4 things have hybridized. That's what tetrahedral means. So S is the first thing, and then 3 P's. And that gives us 4. There you can see my fingers. All right. All right. Ether, be careful. It doesn't show the Mickey Mouse ears, but you can put them there. This is a tetrabent for the, again, these are structural formulas. It's a tetrabent, and tetra is 109 degrees, and tetras are always SP3. So be careful. I actually recommend you put in the Mickey Mouse ears when you do study set 2 and worksheet 2. You're going to see a lot of structural formulas. So be careful. Nitrogen, you will add that 1 lone pair on a lot of them, and the oxygens, you will often be adding your 2 set of Mickey Mouse ears. So like here, we can add our dots, and these hydrogens would be around it. And so some students, it is helpful. They like to visually see it. And some are okay with it written like that. And they're like, okay, there's 4 things around that nitrogen. So it's going to actually look just like this, just flipped because it's on the other side. So again, it's an SP3, 109-ish. And so we don't want to just say tetrahedral because there is a lone pair. It's a tetrahedral pyramid. And you can say just tetrahedral pyramid because the term tetra tells me it's a triangle base, or you can put the triangle in front of the pyramid. All right, we got this. So the next one, anyone? Anyone? Oh, Carolina. She's like, oh, that one's easy. There's 4 things. That is a tetrahedral. I got this. SP309. All right. Ready? Who can I call on now? Jim. Jim's like, I already did this. Planar triangle. There's 3 things around that starred carbon. 120 SP2. 1, 2, 3. All right. Let's see what happens on the last one. So that is shown exactly how it is. It is straight across. That is linear, as we all say it in unison, 180 degrees. So only 2 things hybridize. S is always the first thing, and then we just need 1 P. We just don't show the superscripts 1. And actually, that's something, these 3s on the SP3 or the 2 on the SP2, those are superscripts. It's just how it's done. So it's just how many things have hybridized. And there you go. You can pause me anytime. I'm going to move on to the next page, which will be page 20. And I'm going to do this one with you also. The pages I'm not are going to be these last 2. And these are going to be the 2 pages you submit. I do not need you to submit any of the rest of it. In fact, maybe I'll take off a point if you do, because it means you didn't follow my instructions. So you didn't watch my video. All right. So let's go ahead and do this. So again, pause me and try it, or do the first one with me and then pause me. The trick is I start at the end with hexane. I'm going to show these 2 ways because some people like the sticks and some people like showing carbons. So I like the sticks. I do 6 zigzags. So 1, you know, get a number 1, 2, 3, 4, 5, 6. So there's 6 positions. And then this is saying that we're going to put 2 chlorines, 1 at number 2 and 1 at number 3. Now, if you do the zigzags, when something goes up and you have a mountain peak, you put the extra piece going above it. And if you have a valley, you put the extra piece going down. So that's doing it zigzags. If you would prefer, you can write it out as the carbons. And if you write out the carbons, so 1, 2, 3, 4, 5, 6, and then at number 2 you have a chlorine, and at number 3 you have a chlorine. I just like showing them opposite because it doesn't get as crowded. And then there is a shorthand way. You do have to show your hydrogens if you write in the C. If you do the zigzag, you do not show hydrogens. And online there's so much like random stuff, but these are 2 accepted. There's one other way, and I'll show it on the next one, that you can show it, and I'm okay with either way. And it's more, you could recognize it. I usually do zigzags. All right, this one is not hexane, it is cyclohexane. So you do a hexagon. That's why pencil is really nice. Any place can be number 1. Wherever you declare number 1, the one next to it would be 2. So we put a chlorine at 1, and we put chlorine next to it. You do not show hydrogens because you don't show carbons in the cyclic. All right, let's do this one. So I'm going to draw it out first with carbons. So penta means 5, and then I'll show you the zigzag. And then this 2 is where the YNE is, which is a triple bond. And it's always the lower number, so 2 to 3. And then at number 4, so 1, 2, 3, 4, number 4 will have a methyl, which is a CH3. So methyl means an extra carbon sticking off, and you can show it above or below. Now you can show your sticks around for your carbons like we did here, or you can write them in. So my first carbon is going to have 3 hydrogens. My second and my third, they already have 4 bonds. And they often will show these like all crunched together. All right, number 4 has 1 hydrogen, and number 5 would have a CH3. So again, you can show it with sticking out like this or like that. If you're going to do the the zigzags, this one does not zigzag much. This is carbon 1, this is carbon 2, this is carbon 3, this is carbon 4, and then we zigzag up to 5. And then 4 also has the side group. So that's what that one would look like. All right, let's go over here. Toluene, that was a special one with benzene. So benzene was our ring. That's this guy here that I still have made. Now has a carboxylic acid, but it's the one where we can show it as alternating double bonds, except they are not. That's the only way I can make the model. The way I like to show it is that it's a delocalized pi bond. So these are all 1.5 bonds. And I am not great at hexagons. I don't expect you guys to be perfect. Some of you will be. All right, and then there can only be one thing at each corner. So toluene means we have a benzene with a CH3. That's how you show a CH3. You can write the CH3 in. If you write it in, then you have to write in all the other things that come around it, or you can just show a stick. So that would be 1, and then this would make this 2 and 3. So ethyl means 2 carbons coming off at 2, and another 2 carbon coming off at 3. That's why I like the zigzags. It makes it look like a little bug swimming with a periscope. He's got a big eye. It's kind of looking at you going, ooh. All right, hopefully I didn't creep you out. Pentanol, zigzags. And then my OH would point up, or you can show your carbons 1, 2, 3, 4, 5. It doesn't matter if your OH went up or down. Make sure the bond is to the O because the H is sticking off. And then you can either write in your hydrogens or you can just show lines. Again, when we don't show carbons, we just show the zigzags are always carbons, and anybody with training would show. All right, pentanone. And again, since mine are peaks at number 2, it points up. I wanted to remind you it was something I did on the other page. It doesn't matter. It does matter if you count from left to right. Some people do like to count from right to left. The double bonded O has to be at the lowest number possible. So these are the same. It's just a mirror image. I'm going to erase that. And you can also write it in showing all your hydrogens like that. This second position already has 4 bonds. So 3 and 4 would be CH2s, like we had here. And then my last position would be CH3. So this is another way where they put them all next to each other instead of showing a line in between like I did up here. And I skipped one. This is an amine. This means nitrogen. Amine means nitrogen, like amino acid. And this is part of the problem with eating lots of protein, because our body doesn't need a lot of nitrogen. It does need some, and it has to get rid of all the extra nitrogen, and it's your kidneys. And they know that. That's why the paleo diet was around for a couple years. It was a fad, and then it disappeared, and it's not out there. You don't see people talking about it as much because people were eating too much protein. It's actually a joke out there. Oh my God, people were destroying their kidneys. You caused, and that is for all of you who are into like bodybuilding, really be careful. You can really hurt your kidneys, and your kidneys are amazing. All right, nitrogen's going to have 3 things around it. It is absolutely optional on these. Lewis structures, you have to show the dots. So if I say draw a Lewis structure, you have to show the dots. All right, we have to put something around it. So on one side, we're going to do an ethyl. So let's do an ethyl on this side. And so I'm going to do it as a zigzag. Do my methyl down there. And my propyl will be 1, 2, 3. So this is 1, 2, 3. So this would be a propyl. This is my propyl. This is my ethyl. This is my methyl. You can show them on any side you want. Those of you who like to draw it in, you would write them. And you can show your sticks. And I didn't give myself enough space. And then on this side, you can write it in like that, or you can show your lines around like that. They're all the same thing. All right. And you can pause me and go back and try it because you want to have a familiarity. You don't have to have, I don't expect you to learn all organic chemistry in 2 hours, but to have a respect. So we're going to try these and we're going to number. Let's do the bug first because he's pretty easy. I see the hexagon. So that is cyclohexane. Now, I just realized the folly in me doing this one. It does matter where number 1 is when there are many things on the ring. and it is the alphabet that determines it. So this is little bug legs, 1, 2, 3. That's a propyl. And this is 1, 2, 3. So this is a propyl. And this is 1, 2, 3. But this is a different propyl. This up here is called an isopropyl. So you've all heard of isopropyl alcohol. A lot of people, every year, somebody picks that as their topic because they work with it because it's an industrial cleaner. It's really stinky. It's called IPA by a lot of people. It's used also in the hand sanitizers that we're all using because it can get in and denature the protein in the cell wall. Soap's even better. And that's why they say soap, because this virus, the COVID virus, has a fatty coating, a non-polar hydrophobic coating, and soap can get in there and break that down. And so that's why soap's so important. But if you don't have soap, isopropyl will. And all right, this will come first. It's called iso because it's attached to the middle. So we would say 1 isopropyl. It's a side group, so we call it isopropyl. If it was an alcohol, this would just be an OH there. So that's what isopropyl alcohol is. And then this would be 2, so this would be 3, 4, 5. So 1 isopropyl, 3, 5 dipropyl, because there's 2 of them, the 2 bug feet, cyclohexane. And YL is when it's a side piece, it's not the main part. The ane tells us everything with single bonds. All right, let's do this one. Triple bond is special. And this is how we would number this. 1, 2, 3, 4, straight across. And then any one of these could be number 5. So this is pentyne. So pent for 5. And YNE is the triple bond. And yet tell me the triple bond is at number 2. And then we have these extra pieces here. They're just one stick. We didn't show carbons. So those are methyls. And they're both at number 4. So 4,4 dimethyl. All right, something I kind of ignored, and I'm sure it's in the writing, and those of you who read, when you have 2 numbers, we put a comma. I don't really care. Your organic chemistry teacher will, but that is how it is done. And between numbers and words, we show a dash, and my pencil isn't showing all my dashes. Those are minor things. Just in case you were wondering and you're like, oh, why didn't you mention that before? I've been wondering for an hour. I'm so sorry. All right, this one is saturated. A reminder of that word. Saturated means there's no double bonds. There's no triple bonds. This is very stable, as was our cyclohexane, but very stable. There's nothing extra special about it. There's no OHs. This is our fossil fuels. We eventually all break down and become this because this is the lowest potential energy. There's nothing extra, nothing special. So we are going to name it, and you want the longest continuous chain, which is that piece. And a reminder, single bonds rotate. I lost my nice, beautiful, long single bonded molecule, but single bonds rotate. So this is similar like these zigzags up here. And we start numbering number 1 at the end that has something coming off of it closer. So if I started over here, 1, 2, 3, 4, I don't get a side group until 4. That's why I'm going to start up here, 1, 2, 3, because this is my methyl. And then at number 4, this elbow is an ethyl because it's a 2 carbon group. And then 5, 6, 7. When I teach this with my other class, it's the first lecture, and I talk about it's finding the longest chain, the longest continuous chain. It's like a Pac-Man game. So we have 7, and 7 is an unusual, 7 is a heptagon. So it's heptane. So the ANE is telling us that it was saturated. And then we have to say that we have an ethyl and a methyl. The order you put it in is alphabetical, and I will move my name up here so you can see it. So we have heptane is the ending. I always write the ending first because it's my longest. So my ethyl goes first. And so we have 4 ethyl, 3 methyl, heptane. And there you have it. So a few things. Again, the only thing that you are submitting, because otherwise it's so many files for me to try to find these 2 pages, are these 2 pages. So you do have to upload it. You'll have figured this out because this isn't due until week 3. Oh, the day of your midterm. So you want to make sure you have a good understanding. I'll have those office hours. I would do this early. So on Tuesday, if you have questions, you can ask me about it. So you can use the rest of that week for studying. And yeah, and you can absolutely come to office hours and I will answer questions because I would love for every single one of you to get a 20. In fact, if a bunch of you have questions, we'll just walk through the whole thing together to make sure those of you who are there have 20. That's it. So you can sign off. My video is going to keep going because, you know, I wrote a story for you guys. And I don't think anybody reads my stories except me. And I used to read them to Joey when I was writing them. And now Joey's turning 22 tomorrow. Can you believe it? I was in labor at this point 22 years ago. And it was a beautiful, beautiful sunny day. So a very nostalgic day. And then it's also Good Friday, which is a very important day to me also. So it's really, and it's beautiful sunny. But I'm going to read you guys a story before I go. So you can cuddle up and take a nap. That's what the little kids would do when I was at the elementary school. The gnome and the Yeti. The Yeti's here. He's listening. I have a printer that prints in color. And there's the gnome. The cow's going to come and listen too. But you can stop the video and just like be like, I'm not going to listen to her read to me. It's 2 pages. Holy moly. There's actually a piece I get to insert because of the incident happened last night during our office hour. All right, Lead. Lead was energized. Aluminum had invited him over for the evening. As he buffed his oxidized coat, he thought through his game plan. This would be the night, finally. He had his moves carefully choreographed in his mind, but when he arrived at Aluminum's humble square on the periodic table, he was not pleased to be greeted by Aluminum's older sibling, Gal, who welcomed Lead to game night. What, the hydrogen was game night? Aluminum's box was filled with metals. Lead nodded to copper, nickel, and cobalt huddled together, each eyeing aluminum covetously. They were much less dense and had never had any problem alloying with aluminum. Silver and gold were playing musical chairs, searching for the perfect lighting to show off their lustrous auras. Aluminum gave Lead a smile that erased his anxiety. Or did it create more anxiety? Lead responded with his usual goofy grin and said, "Hey, how's it going? Nice square." Oh, geez. What kind of comment was that? Nice square? Who comments on a square? Lead wanted to hide under the square. That's the type. A loud thud on the door, and in walked Biz with the dense boys, Oz and So much for a quiet, peaceful evening alone. Lead pondered. Perhaps he could just sneak out. No one would miss him in this crowd when he felt a surge of electrons run through him. Aluminum had grasped his outer orbital and was leading him to the square to sit beside her. He was to be her partner. Well, this was groovy. He would definitely stay now. Game on. Lead mused about the intimate conversations as they discussed strategy, whispering in each other's orbitals. Lead was lost in his daydream when he heard Biz declare it was odds versus evens. W2H? If a look could make Biz's nucleus decay faster than once every several billion years, then Lead's iridescent neighbor would be shedding a heck of a lot of alpha particles right now. But it wasn't Lead's disbelieving gaze that could have incinerated Biz. It was Aluminum glaring at Biz incredulously. Whoa, thought Lead, his electrons buzzing a bit more in their orbitals. Aluminum, always the hostess with the mostest, graciously rose casually, bumping into Lead. Lead was not the only metal with his tongue hanging out as he watched her casually walk around the square and sit poised between Biz and Gold. Hubba hubba. Aluminum sat directly across from Lead, intently staring at him as if she could see into his nucleus. Oh, thank goodness. it was stable because that gaze was hot enough to decay lead's protons. Had someone turned up the heat? Lead's electrons were vibrating so intensely that he rose to a +2 state. He had absolutely no clue what game they were about to play or what the rules were, nor did he care. Lead was completely lost in aluminum's lustrous eyes when someone bumped him out of his fabulous fantasy. Oz had declared that the odds were courteously allowing the evens to take the first move. Well, what did that mean? Lead and the rest of the evens seemed to only be there for the drinks and in hopes of alloying. What game were they playing anyway? Scrambled organics? What did any metal know about organic molecules? Lead found them rather boorish, and ever since that neurotoxicity square had removed lead from gasoline, well, he stayed clear of them. Organic molecules have gained prominence by polluting this planet and creating all sorts of problems. But it was lead who was given the bad rap. It was not fair, Lead brooded as the game began. Each team picked tiles and had to build a molecule and name it. If the other team could modify the molecule into something more complex, they won the round. Lead had no idea what to do and didn't really care. So just put 3 carbons down, stuck hydrogens wherever possible. Propane. Simple enough. Oz clapped him on the back as nickel and zinc toasted him for his brilliant play. Lead was in Carbon's family, so perhaps he was a natural at this game. Aluminum smiled, pulled off 2 hydrogens, added a double bond. Propene. Odds win the first round. Round of volatiles for the evens. Every time they have to do a round, I will say, oh, that's what happens. I might wake you up from your nap. Sorry. Aluminum built a 4-carbon molecule with methyl groups sticking off, 2,2-dimethylbutane. Lead figured he'd just pull the same trick, so he put a double bond between carbons 2 and 3, but that gave the second carbon 5 bonds, which my dear readers know is a no-no. Another round of volatiles for the evens. Lead built a butane and stuck methyl groups at each carbon, declaring triumphantly, 1, 2, 3, 4, tetramethylbutane. Ha ha, beat that. Well, as my dear students also know, methyl on an N carbon just extends the chain. Lead had actually made 3,4-dimethylhexane. Lead scratched his head. He did not understand these organic molecules at all. Too many darn rules, in his humble opinion. Aluminum built a benzene, 6 carbons, and a hexagon with a funky ring in the middle. What the heck did that ring mean? Lead shrugged his shoulders, added 2 chlorines to the top carbon. Oh, wrong move again. Benzene was a resonance structure, Aluminum was explaining. That ring was a delocalized pi bond. What the hydrogen was a delocalized pi bond? Is that going to be on the test? With 6 electrons shared by all 6 of the carbons, in essence, each carbon made a 1.5 bond to the carbons on each side of it. That left room for only 1 attachment at each corner. This organics game was tedious, painful, and a complete disaster. The evens had lost every round and so sloshed from the shot of volatiles they had to take each round that nickel and zinc were already passed out. Those low-density metals couldn't hold their volatiles. Lead looked at Oz. Well, Oz could definitely hold his own, but as the densest element on the periodic table, Oz was really no help to understand organic nomenclature. Across the table, Biz was glowing. She really liked to win. Aluminum sat calmly, staring at Lead whenever he had enough guts to look her way. She must think he's a real dimwit now. But there was a rap on the box. Aluminum rose to answer, and all eyes turned to watch her petite physique shimmer across the square. Why, it was hydrogen and carbon crashing game night. Oz and hooted and called the new arrivals over as Aluminum glared, trying to figure out just exactly how these 2 non-metals had found out about the gathering at her humble square. Lead thought she should just slam the box shut. That's what he would do, but she was too gracious. That's when Lead realized why Aluminum was so upset. Whosever team Carbon was on would win, no contest. Organic chemistry was all about him, after all. And Carbon was number 6, and even. Carbon sat down next to Oz. Hydrogen refused to leave Carbon's side. Number 1 here, airhead on the periodic table. Gold and silver stood in protest. Gold hefting copper over her shoulder as they left. Good riddance, thought Lead, as he realized if he could linger just long enough for all the other elements to leave, he would be alone with Aluminum. Lead sat lost in his daydreams, staring dreamily at Aluminum as Hydrogen, so I'll know if any of you are still listening. Hydrogen lit up a bong, number 1 airhead on the periodic table. Oh, geez, let's delete him from the Zoom session. Who lit this guy in? Was that you, Megan? Oh, gosh, he doesn't belong here. All right, moving on. Now, Aluminum did not meet Lead's gaze. She was trying to match Carbon's move, but even her impressive intellectual prowess couldn't outdo the master of organic modeling. For every isopropyl she added, he turned it into a terbutyl, whatever that is. For each alkene she'd played for double points, Carbon twisted it into a cis-trans isomer for triple. Carbon oxidized the secondary alcohol into a ketone, their double-bonded oxygen atom. They were worth double points. When Aluminum tried the same, oxidizing the primary alcohol into an aldehyde, Carbon just took the oxidation step one step further, quadruple points, making carboxylic acid. Ethers became esters, amines became amides. Whatever play Aluminum made, Carbon was already one step ahead. Lead realized the error in his fantasy too late. Aluminum and her odd teammates had to take a shot of volatile liquids, in fact, double and triple shots. Gal toppled over Cobalt on the floor. Biz was singing karaoke with Oz and but Lead didn't care about them. Aluminum was so intent on the game, she didn't realize how much alcohol her petite form had consumed until her head finally slumped onto the table and she was out for the count. Lead sighed, shrugged his shoulders, and joined his iridescent neighbor in a karaoke rendition of 99 bottles of ethanol. And with that, you've all fallen asleep. Just like the note, I bid you a good night.